Hi friends, so let's start with our first lab, which is prepare for an AI development project. So in this lab, let's follow along. So first of all, what we have to do, we have to go to Azure AI Foundry portal. So we just have to go to ai.azure.com and then we will be directed to Azure Foundry portal. So in Azure Foundry portal, what is the next thing that we have to do? So we have to close any tabs and then click on Azure AI Foundry logo, and then this kind of screen will be shown. So we are getting the same screen. So now what we have to do, we have to create an Azure AI project. So for that, the first step is go to explore models and capabilities. So here we are, explore models and capabilities, and then we have to search for GPT-4o model to see its details. So let's go to GPT-4o model and let's see what is in this GPT-4o model. So instead of GPT-4o, we will go for GPT-4o mini because it costs less. So let's do this. So if we go to GPT-4o mini, right? So yeah, so this is O4 mini. We want GPT-4o mini. So I think we should go to full model catalog. So now it's more easy. So now let's go to GPT-4o. So GPT-4o, right? And then mini. So here we found GPT-4o mini. So this is the one we are looking for. Which one? This one, GPT-4o mini for chat completion. So there is GPT-4o mini for transcribe also, which is speech to text, from text to speech also. So text to speech mini, text to speech mini, transcribe, right? And then we have GPT-4o for chat completion. Then we have for audio generation also, mini audio preview, right? Then mini real-time preview is also for audio generation. So we want the task for chat completion, but it's showing different models for different tasks, right? And we have also for Hugging Faces and different providers, one for Grok also, right? So first of all, we can do filtering here. So first of all, let's filter. We can just directly go to GPT-4o mini and then we get the GPT-4o mini, but instead we will search through the filters, right? So let's search through the filters. So if we go to the collections, we have now let's go to OpenAI. So where is OpenAI? Okay, it should be OpenAI. Yeah, this is OpenAI. So we selected the OpenAI. So for industry, we can select any industry also, but right now we don't have any requirement for the industry. Then capabilities, we can have different capabilities like a reasoning model, which have capabilities of reasoning, model which have capabilities of tool calling. We don't need that also right now. For deployment options, we would need serverless API, right? So this serverless API is the one we call, the standard, and managed compute is the provisioned one. So serverless API we will select, right? So this is the deployment option. We can discuss this in detail, but this serverless API is similar to the standard deployment, and managed compute is similar to the provision deployment. So in this, we are not reserving anything in serverless API. It's just based on your usage. So the cost is based on your usage of the model. While in managed compute, it will not be based on the usage. It is being reserved for you. So we'll use deployment option as serverless API. So inference task, so we want chat completion. So we got OpenAI deployment option serverless API and inference task chat completion. So fine tuning tasks, so we are not fine tuning our model, so we don't need fine tuning task in these cases. And licenses also, uh, we do not require that also to filter that off. So right now we have all those models which have serverless API option and task as chat completion, and they are from OpenAI. So now we want to go for GPT-4o mini. So this is GPT-4o mini. So let's select this. So now it's loading. So this is GPT-4o mini model. So as you can see, these are the details. So they are telling that GPT-4o mini has broad range of tasks, low cost latency, and lot of things. They have also mentioned the context window is 128 tokens, and knowledge is up to October 2023, right? And then they have compared it with GPT 3.5 Turbo. So now here you can see the input and output. So in input it supports text, image, and audio, and in output it gives us only text. So that is supported data types. And then supported languages, it's not just only support English, it support other languages like there. I think this FR is for French, IT might be for Italian, UK might be for, I don't know, Ukrainian or UK English, I don't. So yeah, so this is the supported languages, supported data types, and you can see like the training. So the training data last updated. So the data on which is trained, it was last updated on September 2023, right? And then let's go to this. So here are relevant documents for responsible AI consideration and what responsibility principles they are using in this model, then content filtering. And there are more details about model provider. So as you can see here, so this GPT-4 mini surpasses GPT 3.5 turbo. So here you have different metrics. So like MMLU, MSGM, Human Evolve, and MMU, right? And it has compared it for GPT-4o mini with Gemini Flash and with Claude IQ. So these are the metrics for the tasks, right? So let's understand that also in detail. So if we go to this, so we have first the Human Evolve. So Human Evolve is a benchmark created by OpenAI, which is used to evaluate code generation capabilities of AI. So it basically evaluates the code generation capabilities of our model, and it supports it is given 165 programming problems, and it uses this pass at the rate k matrix, which means that uh, in the k generated solution, if any of the k generated solution pass all the test cases, then it is the pass k matrix. So like if we are calculating the pass one matrix, then all the models which generate solution the first time, which pass all the test cases the first time, they will be basically here, right? So then there is MMLU. So this is massive multitask language understanding. So what it evaluates? It evaluates the knowledge and reasoning capabilities. So what we have done, we have taken MCQs from 57 diverse subjects, and then we are putting those MCQs in the LLM with the zero shot or few shot prompting. So we are just giving little bit of examples also, or no examples. So on 57 diverse subjects, we have given the MCQs to different language models, and based on that, if the what is the percentage of correct MCQs answered by the LLM, we are calculating this MMLU. So MMLU is for massive multitask. Why we are calling multitask? Because there are 57 diverse subjects from STEM, humanities, social sciences, and language understanding. So it is basically reasoning and the knowledge capabilities. So that's why massive multitask language understanding. Then there is MSGM, which is multi-grade school math. So it is testing the multilingual reasoning. So it is multilingual grade school math. So it is just testing the multilingual reasoning and chain of thought reasoning. So the model is given 250 grade school math problems in 10 different languages and with a chain of thought prompting. So the model has to explain all his thoughts and has to deal with all 10 different languages and reason about it. So that is multilingual grade school math. Then the next is massive multimodal multitask understanding. So massive multimodal multitask understanding is same as massive multitask language understanding, but in addition, it also have MCQs which have images in it. So that is the difference between MMMU and MMLU. Then the next is latency. So latency PX. So basically, the latency is calculated. Latency is represented as latency P90, P50. So what does this P90, P50 means? So if we are calculating latency P90, so it means that 90% of the requests are faster than this value. And what we mean by latency? So latency is the time to first token. So lower the latency, better it is. So time to first token is the latency, and throughput is how many number of tokens per second. So throughput is basically number of tokens per second. So if it is higher, then it is better. And cost per million tokens, you know that cost should be lower. So this is all the benchmarks. And then the quality index benchmark. So it is basically a composite score for evaluating language models. So it measures model capabilities in various scenarios, like in various capabilities like reasoning, maths, knowledge, question answering on a scale from 0 to 1. So it is a composite score. Composite score means it is aggregate of different scores. So it is like aggregate of several accuracy scores. Higher this value is, the good the model is. So this is the one of the benchmarks, right? So these are all the common benchmarks. So now let's move to our, you know, the details from the model provider. So where we can see these tasks MMLU. So it's basically testing the reasoning of text and vision on like different law, doctor, STEM, like different topics, right? So it was the MCQs, right? Then MSGM is basically for the math reasoning. Human Eval is basically for coding performance, and MMU is for multimodal reasoning. So all of these codes are here representing that GPT-4o mini is scoring better in all of these, right? So that is what they are telling here. And so we have the input output, also supported languages, training data last updated, right? All of this has been taken care of. Now let's move to our model ID. So here you can see the model ID. So this model ID is very essential when you are working with the programming languages. So when deploying the model in code, you have to use this model ID. So this is the model ID. So when you deploy your model in the code, you have to come here and copy this, right? And then there is a AI quality index, so it is 0.72, and estimated cost is 0.26 USD per 1 million tokens, right? So now let's move to benchmarks. So if we click on benchmarks, so here are the benchmarks. So at the top, you can see that there is 0.72 quality index for this, and 0.26 USD per 1 million tokens. So this is the estimated cost, right? This cost is estimated cost, right? And then there is 0.89 second time to first token. So this is the latency. So the latency is 0.89 seconds, right? And then this is how many tokens are generated per second. So 73.83 tokens are generated per second. So this is throughput, and this is latency, this is the cost, and this is the quality index. So the quality of AI, right? So this is also like a benchmark kind of thing, right? So let's compare this. So they are comparing these four models. So they are comparing GPT-4o mini with 5.4, Llama 4, Maverick, right? 17 billion, and then O3 mini. So in the quality index, the higher it is better. So you can see GPT-4o mini is not good in quality. O3 mini is much better. And then estimated cost, the lower it is better. So you can see that GPT-4o mini has very less cost, just 0.26, whereas O3 mini has 1.925. So it is 1.925 USD per million tokens. Then for the latency, it is time to first token. The lower it is better. So here GPT-4o mini has lower latency, so that's good, right? And then throughput is generated tokens per second. Higher is better. So in this case, O3 mini is better because O3 mini has higher throughput and GPT-4o mini has lower, right? So that is what this is telling. And here you can go in detail. So in AI quality, so here you can get accuracy also. So in cost, the estimated cost is 0.26, but here it is like it gives us the input token cost per million tokens and output token cost per million. So it is 0.15 and zero point 0.6. So it gives the exact cost for the input tokens and the output tokens, right? And then there is latency. So in latency, you can see here is LP50, LP99, right? So LP50 is means 2.41 seconds. So that means that 50% of requests are faster than this 2.41 second. And P99 means 3.9191. So P99 means 99% of the requests are faster than 3.91, right? 3.91 seconds. It's faster than that. So this is how the latency is calculated, and the mean latency is 2.53, right? And then there is throughput. So throughput is also calculated here. This tokens per second, so, and the request per second. So tokens per second is 427.4, and the throughput request per second is 0.41. So this is all about the matrix. So this is in the table format, and this has more details, and here we can compare it with different models, and we can also compare this with more models, right? So we can go from compare with more models here. So this is the one way we can come to this page. The another way is if we go back, and if we just come here and just click on compare models, then we can come from here also. So here it has already generated. So for O3, O3 mini and 5.4, right? So for us, what we want to compare. So x-axis show the cost. So it is USD per million tokens, lower is better. And quality index is higher is better. So on y-axis we have quality, and on x-axis we have cost, right? So we can see that 5.4 has lower cost and lower um, quality index, whereas O3 has higher cost and higher cost index, and O3 mini comes in between, which has uh, not that high cost and not that high quality index. So let's compare our what we want to compare. So let's move to this, right? So we are GPT-4o mini, so we will compare GPT-4o mini. So uh, let's delete all of these, and let's go to the models that we want to compare, right? So we will compare GPT-4o mini, right? So for GPT-4o mini, so this one, and then another one we will compare um, GPT-4o, right? That will be also one of the one, and the other one we will compare is GPT-4o mini, GPT, and 5.4 mini instruct. So we will compare that also. So model to compare 5.4 mini instruct, 5.4, right, mini instruct. So this is the one where it's so yeah, this is the 5.4 mini instruct. So as now you can see, this is 5.4 mini instruct, which has a very low quality index score, and also very low cost score. So it is good if you do not want a high cost, right? Then there is GPT-4o, which has very high cost and also very high quality index. And then comes GPT-4o mini, which has a very high quality index as compared to this one, and also very low cost. So GPT-4o mini is the one model which I will go, because it is also having high quality index, and it is also having a very low cost. So I will go with this one. So this is how you can compare. So in the quality, not on the quality index, you can also compare the accuracy. So if you compare the accuracy also, it's almost similar, right? So we can compare other things also. So like if we want to compare latency, so you can see latency of this is more, right? And similarly, let's go to the quality only. So you can compare different metrics here. You can also go to the list view. So in list view, you might have this you know this option for the models and the model version, and then there is data set also. So you can basically click on this. So truthful QA, so it tells you about the data set. So truthful QA is a benchmark to measure whether language model is truthful in generating question and answers. So it comprises of 817 questions that span 38 categories, including health, law, and finance and politics. So this will tell you about what this data set is all about. So this is 8.5 thousand high quality grade school math word problems, right? Created by human problem writers. So this is also the data set on which it is being trained, right? So this is also you where you can go to the list view, and then here is the model leaderboard. So it tells you what is the high, like Grok 4 is higher at this time in the quality. 5.4 is good for safety, Minstrel 3B is good for cost, throughput, GPT versus 120 billion is good for this. So these are the models, and now we will select GPT-4o mini, right? So let's select GPT-4o mini. So let's go to the search GPT. Okay, 4o. I think I should put this dash here. GPT-4o mini, right? So here we get GPT-4o mini for chat completion. So we click on that. We have read everything. So we can just go and use this model. We have seen the benchmarks, we have seen the licenses, the details. So we can just go and use this model.